Okay, let's get started on this exercise where we are given the head of a singly linked list and we want to reverse the list and return the, it doesn't say it, return the, oh, it doesn't really say it here. We want to return the head of the reversed list. Okay. But yeah, so that's what we want to do for this exercise. And so the other thing it says here is it says a linked list can be reversed either iteratively or recursively. Could you implement both? Yes. So we are going to do that. And the first thing that we're going to do is we're going to start with the iterative method because this is more straightforward. Okay, so let's get started with this. So what we're going to want to do is, let's just use an example here, like we have here. We'll make it like a little bit shorter of an example where we have 1, 2, and 3. And just because nodes of linked lists, if we look at the definition here, they have two attributes. They have a value and they have a next, which points to the next node. But it can also be none if it's the end of the list. So I'm going to, at the end of this final node here, I'm going to write this to denote that it is pointing to that the next attribute of this final node is none, because I want to keep track of every node and the next attribute of every node. So that's what I'm doing this. Okay, so we are given this, and we are given the head of the linked list. And so basically what we want to do is we want to go through and make all of the arrows point in the opposite direction. So we want 1 to be the end of the list, so 1 should be pointing to none. Then we would reverse this one, then we would reverse this one, and then we don't need this anymore. Okay, so that's the basic procedure that we want to go through. And if you look at like how I did that and what I think is like the natural way to approach this is that we start at the head and just move down the list and reverse each arrow. And so that's what we're going to do with the iterative approach, is we're going to have some marker here. I'm going to write this head up here. So head is referring to this first node here with value 1. And we're going to use cur to refer to this as the current node. And basically what we're going to do is we're going to start with this current node, update the next node to what it should be, and then move down the original linked list and update the next node, and then the next node after that, and then the next node after that, and then we're done. Okay. And so if we want to update these nodes, what other variables are we going to need? Well, if we just have this current node here, this doesn't tell us anything about what was the previous node in the original linked list. And so we're going to need another variable. I'm just going to call it prev. So this is going to keep track of what the previous node was in the original linked list, because this is going to be the node to where the current node will be updated to point to. The current node the next attribute of the current node will be updated to prev. But then we also need to keep track of what node we're going to look at when we're done working on the current node. And so with this, with the list as is, we already have that information just by looking at the current node, because the current node is pointing to the next node. But once we update the current node to point to the previous node, we will no longer have any way to keep track of what the next node to look at should be. And so we are going to need another variable to keep track of the next node to look at. And I'm going to call it next here, but when we write it out, we're going to need to refer to it as next node, because next has a special meaning in Python, and so we can't use it as a variable name. Okay, so let's think about what we are going to do here. So we have the current node here, and what would be the previous and next nodes? Well, we want the current node to point. What do we want the current node to point to? Well, this is, once we reverse the list, this node will be the final node, and so it should be pointing to none. And so I'm going to write this again over here, which again refers to none, and this will be the previous node. And then what about the next node? The next node would just be the next one that comes after the current node. Okay, and I'm going to sort of like walk through this the way that we will walk through this in the code. And we should think about that as we're doing this, to make sure that like everything that we're doing, the entire process that we're doing here, is something that we can replicate in code. Okay, so what we're going to do is we know the current node, we know the previous and the next node in the original linked list, and so now we want to update the current node to have the its next attribute updated to what it should be moving forward. And so it is going to point to the previous node here. Okay, so the current node has now been updated, and so this is everything up to here is good and reversed and everything. So now we want to move forward in the iterative process. So we have to think about the way to do this, because we can't just we want to move the previous here, the current here, and the next here, but we need to think about the order, because we couldn't just like update. If we were to update the next node to here, then if we were to try to like update the current node to what we want it to be next in the iteration, which is the what came after the current node in the original linked list, there's no way to access this node anymore. And so we need to be careful about the order that we do these in. And so here's how we're going to do it. We're going to start with the previous node, and the previous node is going to move to where the current node is, because that's where we're going to want to point to. The current node is then going to be updated to where the next node is, and then the next node is going to be updated to the node that comes after what previously was the next node, and what now is the current node. Okay, so now that we have this, we're at the next step in the iterative process, and we know what the previous and next nodes were in the original linked list, and so we're just going to update that arrow so that the next attribute of the current node is the previous node. Okay, and we can see that everything up to this node is good and reversed and everything, and this looks the way that we want. And so now we can move forward in the procedure. Okay, so again, we're going to update the previous node to be here. Going to update the current node to be here. And we're going to update the next node to be here. And so when we're doing this, it's, okay, so it's useful to note here. So this is going to be, we'll access this by current.next. And since this node points to, since the next attribute of this node is none, the value of next is none. So this will be useful to keep in mind. Okay, but now we're going to reverse this arrow here. So we're going to do that. And so we can see here that we've actually gotten to a point where we finished what we wanted to do. Like we have this original linked list reversed and we know where the head is, it's where current is. But we need to think about this, like how we're going to implement this in the code, because we're going to implement this using some sort of loop, and so we need to figure out like when are we going to halt the loop. And there's not a very clear indicator of, okay, well, how would we, what are the indicators of ending the loop? So the value of the value of next is none, and we have updated the current node. Okay, so we know that once those two things have happened, once next node has been updated to be none, and once we have changed the next attribute of the current node, then we are done with the loop. But we'll see when we actually go to the code that there's an easier way to implement this, because it would be tricky to write the loop in such a way that you like check for these specific conditions. So let's keep going on in our procedure to see if there's like a very clear thing that can indicate when we want to stop. Okay, and so what we would do here is, if we were continuing on in the same procedure that we were just doing, we would update the previous node to be equal to the current node. We would update the current node to be equal to the next node. And then we would update the next node to be the node that comes after it, which in this case is also the node that comes after the current node. But we cannot do this because the next node is none, and none is not a node, and so it doesn't have a next attribute. And so we know that we for sure need to stop before we try to move the next node. And a good way to see this is I just want to circle this here, because I want to take note of the fact that the thing that happened just before we stopped here was that we updated the current node to take on the same value as the next node. So that is the indicator of where we should stop. We have updated the current node to be the next node, and now the current node is none. Okay, and so that is a very clear indicator of when we should stop, because that is like a single condition. Once the current node is none, then we can stop. And then what should we return as our output? Well, now with the way that this procedure has worked out, the previous node is actually pointing to what should be the head of, or what is now the head of the reversed list. And so we're going to return the previous one. Okay, So let's start actually like writing this out in code. The first thing that we need to do is this actually, we could wait until we write it out to see that this is necessary, but I'll just add it in here, is that if head is none, then we just return it, because the code that we're going to write doesn't handle the case where the head that's provided is none. And so we need to handle that case individually. Okay, so now let's go through the procedure. If we remember, the first things that we did were we set the previous, the current, and the next. And that was sort of the order that we did it in. And I'm going to write all of the steps out here and write them repeatedly, and then I'm going to show what the loop looks like. Okay, so let's do that. So remember, we started with the previous node being none. The current node is the head. And then the next, which here, again, like this is highlighted, which shows that it's, you can't use it as a variable name. So I'm going to say next node is going to be, well, how are we going to access this? Well, this is the node that comes next after the current node in the original linked list. And so this is simply current.next. Okay, so once we have these nodes in place, what we're going to do is we're going to update the current node so that it is pointing to the previous node. Okay, and then once we've done that, we move the previous, current, and next nodes forward. And remember, we had to start with the previous node here so that we can keep track of where all of the nodes are. So the previous node is going to be updated to be the current one. The current node is going to be updated to be the next, next node. And then the next node is going to be updated to be the node that comes after it. And so we could do next node.next, but we're going to see here that we're going to want to make this code iterative. And so what we just did was we set next node equal to current node. And so we could just do current.next. And so now here, this is the same as this. And we're going to see that now we repeat this process, because now that we've updated all of these nodes, we can update the current node so that it points to the previous node. And then we update all of the nodes again. Okay, and then we'll point backwards. And so here we can see, like, this is what the actual, this is where the iteration is coming in. And so we're going to turn this all into a loop. But now the question here is, so where could the loop possibly start? It could possibly start here. Because these two lines of code are specific to the initial condition. Okay, so we could loop these. Basically, what we have to figure out now is where do we start the loop? Because we see that, like, here, these 4 lines of code are the lines that loop. But we want to make sure that we start the loop in a place such that it will halt precisely when we need it to. So we need it to halt when what happens? We need it to halt when the current node, is none. That's the thing that we said. Okay, and so after the current node becomes none, and before we update the next node. So where does that happen here? These are the 2 lines of code. Okay, so after the current node becomes the next node, and before the next node is updated to be current.next. And so we're going to want to check the looping condition between these 2 lines of code. And so we could go up to where, like, where's the first point that this happens? And it happens to be right here. And so this is where we're going to put in the condition. So we need to loop while the current node is not none, or yes. Which another way to write this is to just say while cur, because this will evaluate to false once cur is none. Okay, so this is going to be the start of our loop, and then we just take these 4 lines and loop them. And we can see that like this, it is a little bit strange that so this is the line of code where the next attribute of the current node is updated, and then updating the location of the 3 nodes is done here, here, and here. So it's weird that it's a little bit disconnected, and that's why I wanted to walk through this process in such detail, so that we could see precisely why the code is written this way, rather than having this this updating of the where the current node points to, rather than this occurring either at the beginning of the while loop or at the end of the while loop. Why it occurs, why it has to occur in the middle. Okay, so anyways, we'll do this while loop, and it will do all the things that it needs to do, and then once the current node becomes none, we're going to be in this scenario, and so it's going to stop before before it tries to set the next node. Okay, so once it stops, what are we going to return? So once it stops, we're going to be in this situation here, where the next and the current nodes are both none, and the previous node is the head of the reverse list. So we're going to return the previous node. Okay. And this is our solution. So let's just check. And it worked. And let's submit it. Okay, so there we go. Yeah, so I know I went into a lot of detail there, but I wanted to walk through the process of like, basically like walking through how the code works, walking through how to go about reasoning through what the code should do, and then also walking through why the loop is constructed in this way. And that finishes the iterative solution here. And looking at the time here, yeah, I am going to stop recording and make a new video to go through the recursive solution. Okay, so that is it for this video and this iterative solution to this exercise.